Welcome to our lesson on NMR spectroscopy interpretation. Today, we'll analyze this proton NMR spectrum and correlate it with the molecular structure. Let's look at the NMR spectrum. The x-axis shows chemical shift in parts per million, or ppm, ranging from 0 to 11 ppm. We can see two main regions of peaks, one cluster around 7 to 8 ppm, and a sharp singlet near 2 ppm. Now, let's look at the molecular structure. We have a benzene ring with several protons labeled A through E. There's an amide group with NH attached to the ring and a methyl group attached to the carbonyl carbon. Let's correlate the peaks with the structure. The cluster of peaks between 7 and 8 ppm comes from the aromatic protons labeled A through E. These protons are in slightly different chemical environments due to their proximity to the amide group, giving rise to the complex splitting pattern. The sharp singlet at 2 ppm corresponds to the methyl group protons. These three equivalent protons produce a single sharp peak. This NMR spectrum helps confirm the structure of our molecule. The chemical shifts and splitting patterns are consistent with an N-methylacetanilide derivative, where we have aromatic protons and a methyl group in distinct chemical environments.